Okay. So if we look at this, when we look at a shape like this, we got to figure out how many lines of reflection it could possibly have. Well, for this shape, it has a horizontal line of reflection and a vertical line of reflection. So it has two lines of reflection. Okay. And then if we think about rotating it around its center, if you rotate it a quarter of a turn, it's not symmetrical. But if you rotate it a half of a turn, it is. So it has two lines of reflection. And then it has 180 degree rotational symmetry. Okay, because you can rotate it 180 degrees and it's on top of itself. All right, so for this shape, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. If it has 10 sides, you can turn it just a little bit, okay? You can turn it 1/10 of 360 degrees, which is 36 degrees, and it's on top of itself. And then another 36 degrees, and another 36 degrees, and another 36 degrees. So its rotational symmetry for this shape right here is 36 degrees, 72 degrees, 108 degrees, 144 degrees, 180 degrees, 216 degrees, 252 degrees, 288 degrees, 324 degrees. It has 9 different turns of rotational symmetry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Because it has 10 sides, we can't count the 10th turn. We can only count 9 of them. Okay? A lot of people make mistakes on that. 10 sides, there's usually about 9, especially on an object like that, there's 9 turns that you can make of rotational symmetry. Because the 10th one brings it back to itself, which is not rotational symmetry. Okay? As far as reflectional symmetry, we can reflect it across this line, this line, this line, and this line, and so on. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of reflection there. 10 lines of reflection. On this arrow, how many lines of reflection do we have? 1. Is there rotational symmetry? No, because you'd have to turn it all the way around until it's back on top of itself. One complete rotation is not rotational symmetry. How many lines of symmetry do you see on the square? 4 lines of symmetry. 4 lines of symmetry. 1, 2, 3, 4. Because you can fold it across this line, you can fold it across this line, you can fold it across this line, you can fold it across this line. Okay, 4 lines of symmetry. Then, rotational symmetry. How far do you turn it until S is on P? How many degrees is that? 90 degrees. So it has 90 degree rotational symmetry, 180 degree rotational symmetry, and 270 degree rotational symmetry. Those are the 3 rotational symmetries it has. Hexagon. How many lines of symmetry does this thing have? And if you say 3, you're only half right. 6. Because there's 1 this way through the middle, 1 this way through the middle, and 1 this way through the middle. And then you got to go corner to corner. So there's 1 this way where it folds, 1 this way where it folds, and 1 this way where it folds. So a hexagon has 6 lines of symmetry. Now, how many turns can you make? Well, you turn it 6 times until it's back on top of itself. So there's 5 turns of rotational symmetry. What are the degrees? Well, how many degrees do you turn it till it's on top of itself? 60 degrees. So the first one is 60. The second one is 120, the third one is. 180 is the fourth one. And the last one. Those are the 5 turns to get it to rotate on top of itself. 6 lines of symmetry, 5 turns. This one. How many lines of symmetry do we have in a triangle? 3 sides. So there'd be one right there to fold it that way. One right here to fold it this way. And one right here to fold it this way. So there are 3 lines of symmetry. Now, this is a 120-degree turn. So how many 120-degree turns can you make until you hit 360? 2 of them. 2 turns. One turn is 120 degrees. The other turn is 240 degrees. Okay? Lines of symmetry, rotational symmetry. This flower, how many lines of symmetry do you think it has? If it has 5 petals. I think it has 5. Let's see. Maybe it has 10. Let's see. 1 there, folds across itself. 1 there. 1 there. 1 there. And 1 there. Oops. I really messed this up. Undo. Undo again. So it has 5 lines of rotational symmetry. Now, if it has 5 petals, what's 360 degrees divided by 5? So every 72 degrees, it's back on top of itself. So the rotational symmetry is 72, 144, 216. 72 after that is 288. And then it would go to 360. So those are the 4 turns. You have 5 petals, so there's 4 turns. All right. Last one. This star, how many points does the star have? 7. So 1, 2, 3, 4. How many lines of symmetry will it have? 7 lines of symmetry. What's 360 degrees divided by 7? It's going to be a crappy number. It's going to be a decimal number. Give me to 2 decimal places. 51.42. So the first turn is 51.42. Cannon. The second turn is 102.84. What's the third turn, Cannon? 150. No, 4.26. What's the next turn, Cannon? 205.68. There you go. There's 2 left. Then we have 257.10. Yeah, 257.10. And the last one is 308.52. Those are the 6 different turns we can make with that one. Rotational symmetry, reflectional symmetry. Hopefully you got the idea behind it. I think your assignment is out there. You still have 20 minutes to work on it. We are done with the chapter. So on Tuesday, we'll take a quiz over 3-4 and then review for the test. Thursday, take the test and the vocab quiz. And then we're done with the quarter.
You